Okay, reaction of aromatic hydrocarbons. As you see in this picture, we have a cyclohexane. There is 6 carbon on the edge of this shape. That's why this is in a cycle. So the name is cyclohexane and it's single bond. That's why ANE is alkane. Plus Br2, if you give it heat from UV light, it's kind of sun, has a UV light in it. So one of these hydrogens, see the hydrogen is not shown, but when you have a carbon here, of course, there's 2 bonds, there need to be 2 more bound, right? Around carbons, hydrogen and hydrogen here. Okay, and Br2 is 2 Br attached to each other, right? Br attached to Br. What's happening is a substitution. One of the Br exchange its position with hydrogen. So these two will exchange. This come here and this is coming here. So that's why you have a Br attached here. And this will become what? HBr. So, and the name of that is because we have boron, you have boromo cyclohexane. Any question, Carlos? Any question?
No.
Okay. So now is benzene plus Br2. You know already what is the benzene. Benzene, when you have a 6 carbon in a cycle attached to each other, of course, at the edge of that, you have a carbon. But the things is that you have a double bond. Every other bond is double bound. Means at this age, you have, as you have carbon, 1, 2, 3. You have a 3 bond, you need 1 more. It means there is 1 hydrogen at each of these carbon, as all of this carbon, 1 hydrogen. So when you have 1 hydrogen here again, and the Br is 2 Br attached to each other. So what is happening is just H and Br will exchange. The H comes here, Br come here. So again, this reaction, you need FBRT as a catalyst for this to happen. So Br attached here and you have HBr. Now, here is cyclohexene. So that was benzene, right? Because you have a sterol, so this is benzene. This is cyclohexene because you have a double bound there, right? Again, here you have 1, 2, 3 bound here. So it means you have 1 hydrogen here and you have 1 hydrogen here. You already know that when there is hydrocarbon with halogen group, the double bond will break, right? When the double bond breaks, what happened? I'm going to do it with the red color. The double bond breaks, then Br, then the carbon here need to have 3 bound around it. Means the carbon has 1 bound here, need to have 1 bound here. One of this Br come here, and one of this the Br come here. That's why you have a Br and Br attached in this position. And when you want to name it on the first carbon, second carbon, you have Br, so it's 1, 2 dibromo. Why di? Because there's 2 of them. Dibromo, and this is cyclohexane. Why cyclohexane? Because you just have a single bound. Any question? Okay. This is addition reaction because there is no other, there's just 1 product. But here that you have a 2 more than 1 product, it's going to be substitution reaction. These 2 examples above is substitution reaction. So if you have done this reaction, the benzene plus Br2 is the Br attached to the ring of the benzene. If the result of that, this Br attached to the ring of benzene, you add another Br2 in it, what's going to happen? The second Br2 will be here, or it could be on a next carbon, or could be here, right? The more 1 and 3 isomers appear to be favored, means the first one and the third one gonna be what is it? The favoring one. This is more happening, right? So you can read through this one if you want. It's just the properties. Now, looking at that, to make sure you know this one better, I would like to graph this HNO3, right? What is the HNO3? N has five carbon in it, right? Sorry, five electron in the valence. And we have 3 oxygen. One that has, each oxygen has 6 electron around it, 6 electron valence. I have 3 of them. 1, 2, 3, 4, 5, 6. I have another one. 1, 2, 3, 4, 5, 6. Now, how do we connect them? We have H, right? H will come and make a bond with one of these oxygens. See, kind of we have OH ion. Then for this one, you just make a double bond with the nitrogen, right? For this one, this just sharing the electron with that. For this, what happened? This electron comes here. And when you have nothing here, this empty space will be shared with the electron from the nitrogen. So if I want to draw that, it's going to be N oxygen here. Here is double bond with oxygen, and here it has OH. Agree? So this is consists of the NO2 and OH. Okay. So what happened? You know, you have a 1 hydrogen here, true? You have 1 hydrogen here, and here you have OH and NO2. OH has a negative. So what happened? H will get out, and NO2 will come to sit in itself here. Right? Then what we have, the H coming here, true? OH and H. What is the H and OH?
To water.
Exactly. That's why we have here water. Very important. Any question?
No.
Okay. This one consists of the positive ion, which is that, and Cl, you know, is that has a negative ion, true? We have, this is hydrogen here. So which one comes here? This one or this one? Of course, the positive and positive will exchange, true? If the H is positive, I need to have something positive come and sit instead of that. So these two will come and exchange. So the CH2, CH3 will come and attach itself into the ring of the benzene. And this hydrogen comes, sit beside the Cl, so form a Cl. To name that, you know, 2 carbon is ethyl as a branch. So here is benzene, that your main chain is benzene. Any question? Okay, so here is predicted product. So as we did, you have a hydrogen here, the positive ion, which is CH3, will come and sit instead of hydrogen, this CH3 here, and the H will, that come with Cl, become HCl. We just explained that what happening here. Here, whenever you see double bond, it's gonna break. So we have HCl, this double bond will break. Of course, it need a bond here and it didn't need a bond here. Which one get H and which one gets Cl? Carbon here has 2 hydrogen, carbon here has 2 hydrogen, both have the same hydrogen, but doesn't matter then. So I just put the hydrogen here and steel here, or vice versa. I put steel here, hydrogen here. Microwave here is not applied because most of this carbon has the same amount of hydrogen. Okay. Next one. So here has again Cl, right? And positive, the positive ones, this whole things will come and attach itself here. There is a hydrogen there, they exchange. Hydrogen come for Cl and this one attaches itself here. It's gonna be C2. So it's gonna be again ethyl benzene. Any question?
No.
Okay, so this is page 30. I want you to do question 4, 5, yeah, 4 and 5. And this is page 31. I'm asking you to do question number 2, question number 3, and 4. Okay.
Okay.